our bell ran out, and I thought I'd go ahead and just do a video on 13b because it's very similar to that 13a. And in this case, we're going to start off with the possible rational roots. So a is going to be list all the possible rational roots. So we're going to go plus or minus p over q again. And this time I have 85, and then I also have 1. So I want to list the factors of 85. So again, I do still like to go plus or minus 1, and then plus or minus 85, and then I'm working my way up. I know I wouldn't do 2. I would check to see if 3 goes into it, but remember one of the tricks for 3 is add the digits, and 8 plus 5 is going to be 13, and it's not going to, that number is not divisible by 3. So then I'd go 4. I know that's not going to work. 5 will work, so I'm going to go plus or minus 5, and then I've got 5 divided by 85, so 85 divided by 5 is going to be 17. So I have plus or minus 17, and then I could just go ahead and kind of quickly look. So 6 won't go into it, 7 won't go into it, 8 won't go into it, 9 won't go into it, and I get all the way up to 17. But I'm gonna go ahead and stop for time. So then I have all over Q, and that's going to be just plus or minus 1 because there's a leading coefficient here of 1. So on this one, my possible rational roots are just going to be that numerator. So plus or minus 1, plus or minus 5, plus or minus 17, or minus 8, or minus 80. For B, when I use Descartes' rule of signs to determine the number of positive and negative ones, I'm going to start by looking at f of x. And f of x starts off with a positive number for the first term. I have a negative, a positive, and a positive. So 1, 2, 3, 1, 2, 3. So then I look for changes. So I have a change here, I have a change here, and I then don't change. So I have 2, or remember I'm going to take 2 and subtract 2 from it, or 0, positive, Positive, rational roots, or real roots. Maybe I should say real, sorry, real roots. Then I'm going to look at f of negative x, and I'm going to do the same thing I did with the first one. I'm just going to substitute it back in. It's not going to change here, so it's still going to be a positive. Right here, I'm going to have a negative to the third, and then a negative here, so it's going to change to positive. This one is going to stay positive, and it's going to stay positive here, and then I'm going to go, then I'm going to get a negative on the next one, but then I'm going to end up with just the positive 85. So now I have, again, 1, 2, I have 1, 2, or 0, negative, real roots. Now, I was given that negative 1 is going to be a root with multiplicity of 2. So with that, for C, on using the synthetic division, I want to go ahead and do negative 1. I better get 0 down here at the bottom or I've done something wrong. So I've got 1, negative 16, 50, 152, 85. I'm going to draw the line, I'm going to drop the 1 down, I'm going to get a positive 1, sorry, and then I'm going to go a negative 1 here, then I'm going to end up with a negative 17, and then I'm going to go a positive 17, so that would be then 67. Then I'm going to go a negative 67, so then I have 152 minus 67, and that's going to give me 85, and then I'm going to multiply it times a negative, so I'll have a negative 85, and that's going to give me 0. Now this is going to give me a reduced polynomial, but it also told me I had a multiplicity of 2. That means I have 2 of those roots. So I can take my reduced polynomial and do synthetic again one more time. Okay, so when I do that, I'm going to drop my 1 down. I'm going to have 1. 1 times negative 1 is going to be negative 1. Then I'm going to have a negative 18, and then I'm going to have a positive 18. And then I'm going to get 85, and then I have a negative 85, and then I have 0. So this is my reduced polynomial. It was going to be x squared minus 18x plus 85. Now at that point, I'm going to go ahead and use my quadratic equation. So I'm going to have a minus b, so it's going to be a plus 18, plus or minus the square root of 18 squared minus 4 times a, which is 1, times c, which is going to be 85, all over 2 times a, which is 1. And so then I'm going to end up with, inside my radical, I have 18 squared, and then I'm going to go minus 4 times 85. I've got a negative 16, so that's going to give me my imaginary. So I have 18 plus or minus, the square root of 16 is going to be 4i all over 2, and since 2 goes into everything, I can go ahead and take this as saying as 9 plus or minus 2i, and those will be my other two roots. All right.